Have you ever stopped to wonder what lets a car wheel spin for thousands and thousands of miles? Or how a massive wind turbine can turn so effortlessly in the breeze? Well, the answer is this incredible piece of engineering, usually totally hidden from view. Today, we're pulling back the curtain on the unsung heroes that conquer friction and keep our world moving: rolling contact bearings. Let's dive in and see how these amazing devices actually work. The idea of using something round to make things move easier isn't new at all. In fact, it's ancient. You see the basic principle with the Egyptians, right? Using logs to roll massive stones for the pyramids. Fast forward to 40 AD, and archaeologists actually found a simple wooden ball bearing in one of Emperor Caligula's sunken ships. Crazy, right? Even the great Leonardo da Vinci was sketching them out around the year 1500. But it was really the Industrial Revolution with Philip Vaughn's patent in 1794 that kicked things into high gear for the modern bearing we know today. So you have all these brilliant minds, centuries apart, all wrestling with the exact same fundamental problem: a universal force that just wants to resist motion and wear everything down. They were all trying to defeat the very same enemy. And to fight this enemy, they perfected this: the bearing. Now, the textbook definition says it's a machine member that supports a moving part and confines its motion. But what does that really mean? Well, think of it as the crucial middleman that lets one part spin freely while staying securely attached to another. I mean, they're in literally everything, from your skateboard to a jumbo jet engine. But what is it that makes this one little component so absolutely critical to all of modern technology? Why do we even need it? Because of this. One word: friction. Without bearings, our machines would just grind themselves to a halt. They'd waste incredible amounts of energy and generate so much destructive heat. Bearings are basically our ultimate weapon in the never-ending war against friction. So, how does this little device pull off such a huge job? To really get it, we need to look inside and break down its deceptively simple anatomy. Okay, so take a look. What's kind of wild is that almost every single rolling contact bearing you'll ever come across is built from just 4 essential parts. 4 pieces, all working together in perfect harmony. Let's break them down one by one. First up, you've got 2 rings: an outer race and an inner race. Think of these as the perfectly smooth, super hardened steel tracks that everything else is going to roll on. They're like a perfectly engineered little roadway. Next, we have the stars of the show, the rolling elements themselves. These can be either perfectly round balls or some kind of roller. And this is where the magic happens. By swapping sliding friction for rolling friction, they slash the amount of energy needed to get things moving. It's a total game changer. And last but not least, we have the separator, sometimes called a cage. Its job sounds simple, but it's absolutely vital. It just keeps all those balls or rollers perfectly spaced out. Without it, they'd all just bunch up, grind against each other, and create a whole mess of friction and heat, which, would totally defeat the whole purpose of the bearing. All right, so now we know the parts. Let's get to the main event. That choice, the one between using balls or using rollers, well, that's the great divide in the bearing world. It might seem like a tiny detail, but trust me, it changes everything. So on one side, you've got ball bearings, which use these perfect little spheres. And on the other, you have roller bearings, which can use all sorts of shapes, like cylinders, tapered cones, or even super thin needles. They look different, and that difference in shape is the key to how they perform. And this quote just hits the nail on the head. It's not just about the shape of the little rolling part. It's about how that shape physically touches the tracks, the inner and outer races. That one single factor determines what kind of job that bearing is going to be good at. So here's the crucial difference, the whole secret sauce. A ball, because it's a sphere, only touches the flat track at a teeny, tiny little spot. We call that point contact. But a roller, since it's a cylinder, touches the track along an entire line, and we call that line contact. I mean, just picture trying to stand on a single glass marble versus lying down across a rolling pin. The way your weight gets distributed is massively different, right? And that difference translates directly to what they can handle. Because that point contact focuses the entire load onto one tiny spot, ball bearings just can't handle as much weight. Their load capacity is lower. But line contact, that spreads the exact same load out over a much larger area, so roller bearings can handle way, way higher loads. This one fundamental difference has led engineers to create a whole family of specialized bearings. It's like having a whole toolbox, with the perfect tool designed to solve a very specific problem. Now, to get these specialized bearings, we have to know about 2 basic kinds of forces, or loads.
First, there are thrust loads. These are forces that push or pull along the length of a shaft. Think of a boat's propeller pushing it forward. Well, this thrust ball bearing is a pure specialist. It's designed to do one thing and one thing only: handle those pure pushing and pulling forces with incredible efficiency.
The other kind of force is a radial load, which pushes from the side, like gravity pulling down on the car's axle. So, what happens when you have both kinds of forces hitting you at once? That's where this guy, the angular contact bearing, comes in. It's a versatile problem solver. It has these specially shaped races that let it handle both radial and thrust loads at the exact same time.
Now check this one out. This is a needle roller bearing. It uses these really long, thin rollers, which gives it a huge line of contact. This lets it pack a massive load capacity into a super slim profile. It's the perfect solution for tight spots, like inside a car's transmission, where you're short on space, but you still need a ton of strength.
And here is a true workhorse, the taper roller bearing. By using rollers shaped like cones that run on angled races, it can handle enormous radial loads and enormous thrust loads all at once. This is the heavy-duty hero you'll find in the wheel hub of a big truck, taking an absolute beating from that brutal combination of forces day in and day out.
So, we've gone deep on how they work and the different types. But now let's zoom out for a second and just appreciate the kind of world these tiny components actually make possible.
I mean, the applications are pretty much endless. They're the silent spinning heart inside industrial gearboxes and pretty much every electric motor on the planet. They provide the rock-solid precision in the machine tools that build our world. They carry the entire weight of your car, every truck, every train on their axles. Honestly, pretty much any machine that has a spinning part owes its existence to a bearing.
So, if there's one thing to take away, it's this. From the tiniest, most delicate scientific instruments to the most powerful jet engines spinning at thousands of RPMs, these small, often forgotten components are quietly and efficiently carrying the immense loads of our modern world on their shoulders. They're what makes speed, power, and precision possible.
They are just a perfect testament to how a simple, elegant solution to a fundamental problem like friction can literally change everything. They carry our world today. The only real question is, what new technologies, what new frontiers will they help us carry next?